Continuing in section 9.8, our next type of equation has two radicals in one equation. And to solve it, the very first step is going to be to isolate one of the two radical expressions, then raise both sides of the problem to the power equal to the index. If we still have a radical, we repeat steps 1 and 2. If we don't, then we solve the equation. Always check your answer. Example 2, problem 1. Step 1 says I need to get one of these radical expressions by itself because I have the square root here with the x plus 5 and then the square root of x. I cannot put these together as we talked about when we had a section on adding radicals. These are not like radicals, so they cannot be combined. Instead, I'm going to add the square root of x and then I'm going to square both sides, again utilizing parentheses because this 1 plus the square root of x is going to have to be FOILed. So when I FOIL that, I get 1 plus 2 square root of x plus, then this is the square root of x squared, so it's just x. And I still have a radical in my problem. So this is where it says to repeat steps 1 and 2. So I need to get this radical right here by itself. To do that, I'm going to start by subtracting 1 and subtracting x. Well, these x's happen to cancel out as well. So I have 4 equals 2 square root of x. Divide by 2. 2 equals the square root of x. Square both sides, and I get x equals 4. Checking that, I'm going to have 4 plus 5 is 9. I'm going to write out my check a little bit here. So 4 plus 5 is 9. Square root of 4, does that equal 1? So I have 3 minus 2 equals 1. Yes, it does. So my answer is x equals 4. Part B has cube roots. I already have one radical isolated. Well, actually, they're both isolated. One on each side of the equals. So I start by cubing both sides. Makes my radicals cancel out. And then I have a quadratic because there's a squared variable, which means I need to get everything together on one side of the equal sign. So then we have a squared minus 3a minus 28. Factor two numbers that multiply to 28 and add to -3 are -7 and +4. And then setting each of those equal to 0, I get +7 and -4. Checking both of my answers. 7 subbing it in squared, that's 49, minus 21. Still subbing in the 7. So 2 times 49 is going to be 98. Putting in the 7 times 6 is 42. And then solving it out further, 49 minus 21 plus 5. That's 33. 98 minus 42 minus 23 is also 33. So since it's equal, I know the 7 works. Repeat the checking process with the -4. Putting -4 in place of the a's, we get +16, +12, and then 32 plus 24 minus 23. I'm putting the negative 4 in place of the a in the original problem. When I add, I get 33. And when I add those and subtract 23, I also get 33. So both of my answers did check this time. On part C, I need to get one of these radicals by itself. So I'm going to add the square root of x plus 4. And then I'm going to square both sides utilizing parentheses, because when I square this side, what I'm actually going to have to do is multiply it by itself. Foiling, I get 1 plus 2 square root of x plus 4. And the square root of x plus 4 times the square root of x plus 4 is just x plus 4. Then I need to get the square root of x plus 4 by itself. So I'm going to move this x, and putting the 1 plus 4 together, that actually makes 5. So I'm going to subtract 5, because it's subtracting 1 and subtracting 4 is like the same thing as subtracting 5. So I get x minus 4 equals 2 square root of x plus 4. I could divide by 2. I'm not a huge fan of introducing fractions if I don't have to. So at this point, since 2 multiplies by the x plus 4 in the radical, we can actually square both sides as long as we use that product rule, which says that I'm going to have to distribute the squared in. So I'm going to actually get 4 times x plus 4, because it's 2 squared, and then the squared and the square root cancel. X minus 4 squared, I'm not going to write it out, but it's FOILed. So we have x squared minus 8x plus 16. Distribute the 4. And then, since it's x squared, get everything on one side of the equal. So I'm going to subtract 4x and subtract 16. Solve by factoring. GCF. Get x equals 0 and 12. When we check, when I put 0 back into the original problem, I get 1 minus 4 equals 1, and that is not true, because that's 1 minus 2. And then when I put the 12 into the original problem, I get 25 and 16 equals 1. That is true. So my answer is just 12. One more type of problem real quick, and that is to rearrange an equation. So I'm not actually going to have a number answer. All I'm going to do is rearrange this given equation so the h is by itself. Right now the h is trapped under the radical. To get rid of the radical, I'm going to square both sides. So we have r squared equals 3b over pi h. The h is now trapped in the denominator. I don't like it there, so I'm going to multiply by h. So I have hr squared equals 3b over pi. To get the h by itself, I'm going to divide by r squared, or dividing by r squared is the same thing as multiplying by 1 over r squared. So now h equals 3b over pi r squared. Make sure that you notice the V is capital. MyLabs is case sensitive, so if it's a capital letter, make sure you use a capital letter when you're typing your answer.